All right, so we are live. Let me go ahead and start a new page. And change my view. You guys online, can you all see us? Hopefully I'm not muted. Let me check that out.
Yes.
You can see us. Can you hear me and everything? Make sure you can hear me. Everything good?
Yes, sir.
Yeah, I hear you.
Excellent.
You're good.
All right. So, as I was telling the class, you don't have to show up if you don't want to. The only days you have to show up are test days. There are times when I've taught this, I've done this for years now. I've taught in here like 1 or 2 people have showed up. You know, and then I see this to people online. So they are very, you gotta watch. So, sounds like the microphone is starting to. Now, those people that are on the other side, you've got to mute your microphones. Mute your microphones, please, unless you're going to talk, mute them. All right. So everybody learns how to use it too. All right. So with that said, now we're ready to start the day. Are there any questions? First of all, I'll take care of you like during the break or something. Any questions? Anybody online? Any questions anywhere? All right. And I will go ahead and start. We have two, /2, 0, 2, 2. It says it's Groundhog Day. Well, at the very least, every year that thing is extremely mad. They pull him out of his thing. He just exactly. He was fine.
Probably never wants to come out of it.
He lives like a king. He lives like a king all year round, except for that day. All right. Today is algebraic expressions and properties of real numbers. It's part of 1.7, and you go ahead and pull that up. Yeah, there's a lot of properties and things like that. So we'll just kind of go through them, I think. Yeah, I think so. Let's start with this. Do you know by right? You know that's equal to 8. Same thing. You trust that if I change the order, you get the same answer, don't you? So in other words, if I take a number and add it to another number, we can switch the order of the numbers and we get the same answer. Isn't that true? There's a word for that in math. You know what it's called? You're allowed to switch the order and it doesn't matter. You know what that's called? It's not one of the order of operations. This is a property of the real numbers. It's called commutativities. Now, it's not necessary that you know this terminology, but I'll just use it. I'm not going to ask you on a test, oh, give me the definition of this or that. You're going to do all problems, but I will use the word. Oh, I missed some, didn't I? This is commutativity. Let me fix it. Apparently, it's not select the eraser. And the same thing works for multiplication as well, right? You're allowed to order any way you want when you multiply two numbers. If I switch them, you get the same answer, don't you? So these are all forms of commutativity. Then we have something like this. What if I take the number 9 and I do this? What do you get? 9. Yeah, everybody knows this. I know these are kind of stupid questions are very simple, but each of these things has purpose mathematically. When you add 0, 0 is called the additive identity. Have you heard that phrase before? Almost assuredly you have, you just might not remember it. So basically, when you take 0 and add it to something, you get the same answer you had before, right? It's adding 0 to something. Can you think of something similar in terms of multiplication? What do you multiply by and it does nothing? 1. So multiplication's version is 1. So that's, if I have 9 times 1, that's equal to 9 also. So the number 1 is called the multiplicative. Any questions? Most of the stuff, I mean, there's nothing, I guess probably no questions to say. It's just, these are just rules and we simply have. Right, when you're working a problem like this, what's the part you do first? Excellent. So you're going to do 3 squared first, and you'll get 5 times 9. And that is equal to 45, of course. But now consider this quantity. You don't know its value because what? You don't know the value of x. But do you agree that it looks similar to it? Similar, don't they? The only thing is, if I try to do something like this, if I were to give you this problem to do, and ask you to do it without touching your calculator, could you do it? How so? So you would go through all that. Now, what if I just said, so what are you going to do, 5 times 9 and then 6 times 9? Could do that, or I could save myself a little bit of effort. Do you agree that I have 5 things plus 6 more of the same thing? I have 5 things plus 6 more of the same thing. How many things do I have total? I have 5 of them plus 6 more. How many of them are there? There's 11 of them. 5 plus 6 is 11. This happens to be 11 times 3 squared. What is 3 squared? Now, if we use the other method, which is the more straightforward method, let's compare the answers. If I gave you this at the beginning of the class, or the beginning last time to do this, you would do 5 times 9 plus 6 times 9. Am I correct? Let's multiply them together. This is 45. This is 54. This 45 and 54 add up to 8. So there's actually two ways of doing that problem. Let me continue this theme. All right. How would you do this one? Exponents first. That's a lot of exponents, isn't it? They all have the same thing attached to them, don't they? They all have 7 squared attached to them, don't they? So in fact, I can concentrate. What's 6 minus 13? Not quite. It's -7, so keep with me. -7 plus 9. Positive 2. Positive 2 minus 27. -25 plus 9. -25 plus 9 is -16. Now, inevitably, you were probably going to do this on your calculator, weren't you? That's still a long problem, isn't it? But now it's a really easy one. It'll involve exactly one computation from your calculator. Isn't this the same as -16 times 49? So instead of doing this, which could last the rest of the day, do that. Now, pull out your calculator, tell me what you get.
So basically you're leaving it.
That's right. What I'm doing is I am using algebra, and oftentimes you can use algebra to make your life so much easier if you're willing to go there. So I'm going to do 16 times 49. I get 784. So my answer is -784. You want to check me on this? I guess it's no. I'm not checking it. The whole point of doing this was to avoid that. So what I've done though is I've made use of something in here, a phrase that you probably heard before called like terms. Have you heard that phrase? What we did is we made use of like terms. Every 7 squared term is a like term. You gotta watch, if you make any sound like a cough, they're gonna come in here and take me out of here.
So I have cough drops at the ready for its purpose.
Yes, oh yeah, you don't wanna go in there quarantine. You're done for 2 weeks, you don't even know what age you. These are all called like terms, and you recognize them because you can see them attached to each of the numbers. And here's why they work. You might have heard of seen this property before. Whenever I write A, B, C like this is a formula for all numbers. Have you seen this before? Where you will take and multiply A to B, and then you'll multiply A to C. No. Next right up. It's in that realm. This one's called the distributive property. We exploit that to lengths you wouldn't believe. I'll show you how to do it. If I asked you to do this multiplication, like so, 8 times 56, you either know it or you don't know how to do what your calculator doing. Moment being, don't touch your calculator, I want to show you something. So I have 8 times 56. Now, what if I did this something, have you ever seen a television show or something where they'll have a young kid on or some, like somebody with Alzheimer's, not Alzheimer's, but it's like the Rain Man disease, I forget the name of it. But they'll ask him these multiplication questions, they're huge questions, and the kid will know the answers. You've seen this, kids like this before. One of the tricks that they use is what I'm gonna do next. While I can't do 8 times 56 regularly quick, I can do this. And they're adept at doing multiplications in their head, so this is not a problem. Now, I use the distributive property. Look how easy this is. What does 8 times 50 equal? Like, it equals 400 because 8 times 5 is 40, isn't it? Put an extra 0 at the end of it, you get 400. Isn't that right? That's an easy multiplication. Then we come and do this one. That one you also know, don't you? 8. So we get 400 plus 48 equals. You can do something like this. 16 times 99. You do 16 times 100 minus 1. Reason why, because what multiplying by 100 is cakewalk. When I multiply by 100, don't I just add 2 zeros to the number? This. You'll get 16 times 100 minus 16 times 1. And so you get 1600 minus 16. Now it's a lot easier problem to do. Anybody know 100 minus 16? 6. 100 minus 16 is 84. So that's going to be 1,584. You agree? I'm showing you a little some of the tricks. And these kids, they're capable of throwing all these tricks together and then some that I don't know. That's an idea of what they do. So those kids that use extraordinary powers to multiply things are making use of the distributive property to do it. Let me show you one other thing. Using my method, how do you think I'm going, my method, like I invented it. How do you think I'm going to break up the 43? 40 plus 3. The reason why those numbers are good is because I'm not thinking of 4D, I'm thinking of 4. And 7 times 4 is an easy multiplication. Do you remember before they had you do multiplication, didn't they have you memorize those tables? What you probably spent the first or second grade doing just that. And then they started giving you multiplication problems and make use of those things. Reason why is because trying to do 7 times 40 is not in the multiplication table, but 7 times 4 is. That's why they had you learn, because at each step you would need to use it. Remember, everything you did involved individual digits at some point in the problem. I'll show you when I finish this how that's the case. 7 times 40 equals what? 280, right? And then we have 7 times 3. That's 21. Anybody, what is the final answer?
301.
301. 301. Now, let me show you something that you did in elementary school. You would have probably set up the problem like this, would you have? And then, what's 7 times 3? Is 21 over there anywhere? What's 7 times 4? I don't know why I did that. That was so stupid. I'm not multiplying at all. I have this. I'm not actually multiplying correctly. Let me come back here. 7 times 3 gives us 1. Then we put the 2 up there, don't we? 7 times 4. 28 plus 2 more is 30. But what you actually did is this. Aren't those the 2 computations that you actually did? 7 times 3, you didn't know it, but since that 4 was over there, it was actually a 4D, wasn't it? But I'm telling you, it's the multiplication you learned in school is the distributive property. That is all it was. That's right, yeah, but you know what it is now. Well, in school, you gotta give the teachers credit, they can't take the time to explain this stuff to you. If they had mentioned the word distributive in first grade, you probably would have cried. I don't know about that, but my first grade teacher had everybody crying anyway, so. But this really gets to algebra in the following fact. If I give you something like this, now I'm not going to tell you the numbers, but if I give you 7x squared plus 3x squared, there's 2 ways of thinking about it. How many x squareds do I have total? No, not that. That's not what I'm asking you. I've got 7 of them, and I've got 3 more. How many total? 10 of them. There's 7x squareds there, right? There's 3 more of them. If I wrote it out, you're probably like, I don't know how he's gonna do it. Isn't he? How many x squareds you count? 7 of them. Plus how many more? All right, so plus 3 more. How many of them total are there then? 10 of them. I highly doubt that you would take this problem and do that to it. But hopefully you can understand why you get 10. Now, all you need to do is look at the numbers. What's 7 plus 3? I've got 7 of them plus 3 or more of them. It's this distributive property again. This time I factored out x squared. That's the like term. That's why it's called a like term. It's because you can distribute it. It's common to both parts. 7 plus 3 is 10. And that's the beauty of this, is that you only have to look at the numbers. Anybody know what those numbers are called in front of the x? The x itself is called a variable. Right, the x is the variable. What do they call the numbers in front of them? So what I'm talking about, there's a mathematical word for that number 10. What do they call it? Okay. You got it? Yeah, it's based on what I can do. What the distributive property allows you to do is look just at the coefficients and just add up those. And ignore, for the time being, the horrible looking term that's attached to them. So, so if I give you something as horrible as this, can you tell me what the net of all that is? When you do it, you can, they're all, do you notice they're all like terms? They've all got the same chunk attached to them. You see 13 minus 14 is -1, plus 2 is +1, minus 4, right, is -1, it's 3. So if I just look at the numbers, 13 minus 14 plus 2 minus 4, all of those things were attached to x squared, x to the 5th actually. And then all you got to do is add up those numbers. Once you do add up the numbers, you can drop the parentheses. Any questions about that? So you'll see this terminology then many times. A little bit different than the last problems.
Now I'm throwing in a wrinkle.
Now you can just concentrate on the numbers. What do you get? What about the x's? These are all attached to x's, aren't they? In fact, let me remind you of something. Between the 4 and the x squared, what's going on there, technically speaking? There's multiplication, isn't it? Technically speaking, there's a dot in between those coefficients on the variable. Do you recognize there's two different like terms here? There's the x squareds and then there's the x to the 5ths. So what you can do is this. What I encourage students to do is to move stuff around using the commutative property. So I can rearrange it so the x squareds are together. Similarly, I can shove the x to the 5ths to the back where they're together. You guys with me? Commutativity allows me to move things around. And notice that the negative stayed in front of that 7. When I moved it around, you understand that negative attached to the coefficient. Now it should be easier. You've got 4 of something plus 5 more of the same thing. Is how many of that? How many x squareds? 9 of them. Now look at the x to the 5th. How many of those net do I have? It's not negative. 13 is a bigger number. Positive 6x to the 5th. So here we have a couple of different pairs of like terms. Identifying like terms is a huge, huge aspect in this course. I just don't want to make sure I'm not missing anything. This is a huge section.
So I want to make sure that I capture everything.
Now, those letters, the x squareds, they call x a variable y. Unknown is not the reason why it's called a variable. Because its value could be known to somebody, just not you. That's not why it's called a variable. What are you going to say now?
Oh, because it can be almost anything.
It
We'll sell
It can possibly change values. The x, because what it is we do a bunch of stuff with x, and then when we're all done, we may plug a number in for x. So that is called, when you plug a number in, what does it do? I mean, what's it called? Does anybody know? So we'll see sometimes. Actually, put in a number. What, I left that spot blank. What do you think? I want to use a mathematical term instead of put. That's not very mathematical. Substitute. Remember that term? Plug in the number means substitute it, doesn't it? So we call it, I don't know if I left myself enough space though, so what? Substitute. All right, so with that in mind. This is typically the way it'll work. You'll go get yourself an expression like we have at the end, the 9x squared plus 6x, then we'll plug a number into it. So go ahead and plug it in, tell me what you get. It's not, would you say negative 64? No, oh my God. When you did 2 to the 5th power, what did you get for that? Two to the 5th is 32. I'm guessing that's where you made a mistake with that, if there was one. Your calculators can do this kind of thing too easily. Your calculator. Let me see, if you don't mind, show me your calculators, would you? You're not allowed to use the cell phones on tests, so you might as well get used to using a device like. I wouldn't buy it out of the bookstore though, never buy anything out of the bookstore, you know. This calculator is $500 at the bookstore. That one, but at Walmart it's 10. Yeah. It's not, but they do, it's like $20 for this stupid thing. It's almost half that price at Walmart. So, the reason I mentioned it is because if I know what kind of calculator, I can write down how you would write it into the calculator. So, like if you were to try to do this when x is equal to -2, what we really want you to do is do this. Do you understand that? Whenever you substitute a negative number, it's a good idea to put it in parentheses. Because if you don't, it'll look like a subtraction. Now let me go ahead and do each of these individually, then I'll tell you how you do it in the calculator. What is negative 2 to the second power equal to? Positive 4. Negative times a negative is positive. What is negative 2 to the fifth power? So this will be negative. Negative 32. So I will get 6 minus 192. I believe that that is negative 156. Calculator, it has something of an annoying feature, but I'm not exactly sure what I would do to fix it. So I just want to explain it to you. The way this will look when you do it on your machine is this. You'll have 9, then you'll put a negative 2, and then you'll see this. You know what that thing is? That indicates an exponent of 2, the little caret button. Not all calculators have that little thing. Some calculators have like an X to the Y button. So if you type this on a calculator like mine, it will give you the negative 156. On your cell phone calculator, because all the cell phones are different, I can't even do it because I deleted the calculator off this and put my own on it. But yeah, it'll become scientific if you turn it to the side. Oh, does it allow you to put parentheses and all that? Can you see what you type? Yeah. For some of you, you might have to use a thing called X to the Y. And that'll look like something like this. Just to make it fun, some calculators decide to put the Y down there and the X up there. So make sure you can get your calculator to get this negative 156. Can yours do it? You didn't put it, can you put it like that? Or do you have? Which one are you going to use? Oh, yeah. Once you get a regular calculator, let me know. But on there, turn to the side. Do they use parentheses on this calculator? What do you type it in? See it. Yeah, these are the toughest ones. If I were you, I would spend the $10 and buy, unless that one does it better. But you can't use it on test though. For obvious reasons, you can't use a cell phone on a test. Imagine what we might not allow you to use cell phones on. You think you can get help? No idea. I should tell you, I got at least 15 people that call me up on exams regularly. I make this tons of money. I never thought I could make a ton of money doing that. Never crossed my mind. All right, let's go ahead and take 10 minutes there. We're only going to do 1.7 a day. There's a lot in it, so we'll finish it up when you get back. Question? Yeah, go ahead and take 10 minutes there. We remember we get a 10-minute break in the middle of class. Because it's a 2-hour class, we get. Oh, did I not finish? That's right there. It ended up being negative 156. So there you go. So see if you can get your calculator to do it. You'll want your calculator to be your friend and not your foe this semester. So you want to understand how to plug these things in. Go into Blackboard. Oh, if I'm logged in here, I'll have to log out of Blackboard. So let me get out of this. No, I cannot do it on mine. Let me come here. Okay, see, I'm still logged in, so let me log out of this. Let me move them out of the way. Do it over here. Sign out. All right, go ahead and log in and go into Blackboard. Can you guys able to get to the homework? Okay. He's gonna try to do the rest of these. It's really simple. You gotta sign in, and once you sign in, it knows who you are. Even the Blackboard does. But through here, you're gonna do the homework. Give it a second. It's kind of slow, yeah. You can do either one. You show up or say. You'll get that. When I was younger, in better shape, I was in karate. And even though I liked it, I didn't want to show up. But then watching them do it online, what the hell? Well, we do, but it should be, the WebEx should actually be working. It should actually work.
It's working.
They see my, never mind.
Oh, I see it working. Yeah, you can see the people up there. All right, yeah, click in there. You got it. Now, you can click on continue or go up. I prefer you do it up there because this screen changes a lot. Try to go up there. For assignments. We've only got the one. Remember I told you, only click on HW things. All the other stuff, I cannot delete it. I'm kind of forced to have it there, but I'll just ignore it.
So this right here.
And there you go.
Oh, this, wow.
You're in the homework right now.
So you want us to just complete one of them? You said yesterday?
See it?
Yesterday, you want us to complete one of them?
Well, the whole section.
Oh,
I think there's 26 problems in total.
okay.
But yeah, this is the homework, and it's to, well, you can see when it's, the due dates are listed online, but usually it's a week after I sign it. That way you have a day in class to ask questions, like I asked at the beginning, if anybody had any questions. Yeah, so I promise you it won't stay that, but I know for a fact, in a few weeks, you'll have a lot of questions. You good? Did you sign out?
Yes, sir.
Okay.
Mr. Van Pelt?
He stepped out of the class for a second.
He did?
Yeah.
All right, no problem.
Someone was trying to ask a question over the,
Oh, somebody called, oh, okay.
Yeah, Mr. Van Pelt.
Yes, WebEx person.
So I was just curious, is the online thing optional? Like you can come in person, even
Certainly
though,
can. You can come in or stay there. The only
Okay.
thing is you have to be in here for the tests,
all right, not a problem.
but everything else you can stay home or come in.
And you were talking about a calculator. I was just curious, which calculator is recommended?
I would probably, the easiest, the one everybody seems to have, not everybody, but the easiest one is this Texas Instruments thing. Here, I'll show it on the, you seen these before?
Yeah, I've seen those. Those are the basic ones.
Yeah, don't buy it from the bookstore. It'll cost you double.
Okay.
But then if you have, if you got to use financial aid, you don't have any choice, but nonetheless. It's TI,
Okay.
what is it? TI 30X? That should be fine.
TI 30X.
Yeah,
All right, I appreciate it.
sure. See if they've logged out. Oh, man. I've grabbed some great things from the book. I recommend, if you have not been into this book or anything like this, let me see. I don't know if you see through this book, but all throughout it, there's these clickable things. I don't know what's in them because I don't use the book very, but apparently they give you some examples right there and step-by-step examples. And I keep closing the book and I don't mean to do it. There we go. They give you step-by-step examples, but sometimes, what's that thing? I thought that might be a video. There are videos in there too, so you get a lot of options. For life, I keep destroying that. Trying to find a video. Mapping calculators. What's this you try? Oh, cool. Okay, so they take you to the U-tries directly? Interesting. Well, I knew there were videos somewhere in here, but I just can't seem to find them. Maybe they don't have any in this section, but it seems unlikely. Were these videos, by the way, when I clicked this, did you see a play button anywhere? Hey, what's this down here? What do you know? Okay, well, they get the idea. Interesting. It doesn't let me out of it. Okay, I get it. Stop that. Come back to it. So, okay, there's the videos in there. Let me go. I just want to go down to the homework and just grab some problems for us to try. I pretty much give you most of what you need. Let's just grab some problems. We've done the easier ones. Let's give some of the harder ones. Mixed, that's probably not a bad idea. Yeah, let's do some of those. All right, this is where you guys get to get your work in. Combine like terms and simplify. Anybody think they got it yet? I see a few people I think might be done. What'd you get?
Minus 4p is 2p squared.
2p squared. So what'd you say, -7?
Negative 7 minus 4p.
Minus 4p?
squared.
Yep, that's right. The order doesn't matter, remember it's commutative, so the order can be any.
So the way I personally do it is I look at this guy and I see this, the like term, do you see that? So you don't have to do this part, but I generally do. I'll move them around. Slice them off as I do. You do something like this, so you don't read stuff. That's all the p squares. Now I'll move on to the p's. What do I have in the p's? How many p is that? So I've moved those together. I'm using commutative property for all this. Then finally, minus 10 plus 3, and then we reach -7. So you can see we have the two p squareds. And then 1 minus 5 is -4p. This is 7. Questions about that? That's good.
All right, that one didn't seem too bad, I hope. First, I used to, before COVID ever came around, I would go around and look and see what each of you are doing, but I can't get too close. So I have to do it from a distance. I don't think we need to do a more complicated version of that particular problem, but I do think we need to get some distributive properties in here. So let's throw this one up. All of these are the same things. Simplify by combining like terms. Let me say this, you will know it if you get it. The answer is such that you'll go, oh, yeah, okay. There'll be no question you got it. Anybody think they got it? What is the shape of your answer?
Shape of
Is your answer the shape of an O? As in 0? Okay. This is a 0. Did you guys get 0? Everything cancels out here.
Which most likely, if you made a mistake, it was somewhere in the distributive property, I guarantee it. There's nothing going on with the 9, but when you do this part here, that negative should really be attached to it. I didn't know that was an issue. But something. Isn't it true that there is a dot here? If you do 9 minus 4, aren't you doing subtraction before multiplication? That's bad, right? So, but it's done. I don't know why. It's like almost begging you to do it. But that multiplication says no. So we go and do this -4 times each of these. Here's what I get when I do it. The 9 is not a big deal. What's -4 times 3? But minus 12. That's why I said negatives and minuses are essentially the same thing. What about -4 and minus x?
Positive 4x.
Positive 4x. This thing kind of plays itself up as you go along. You see the 4x's just wiping themselves out, don't they? 9 minus 12 is negative, so this part right here is -3. That part is 0. I don't think I need to do another step for you to tell it, see that it's going to be 0. Can you pause, cancel out? That's why I said, this is one of those answers, when you get it, don't you just feel like, oh yeah, that's got to be the right answer. You can't, if you do that, now that's more complicated. You can do, let me explain what he was trying to tell me here. You choose what you want. I am stressed at how much I should or should not say in class, because while I elucidate something for you, it'll confuse somebody else. So I have to try to wait. But what you're doing is this. Leaving that minus there and then having the 4 go to each of those. Now, what did you do at this stage? What did you do with this? What did you do now? How did you do the parentheses?
Track.
Can't combine them. That 12 and the 4x are not like terms.
Matter of fact, I just did the 4x like terms.
Oh, yeah, well, they're, oh,
To the negative 4. Negative.
so you got negative 8x.
This is like terms. Yeah.
Unfortunately, this is a negative in front of here. That means whatever is inside of there you have to be the negative of. What I'm saying is the next step that you should have done is this. See that? This made everything inside negative. See, that's the -12, isn't it? -12. Isn't positive 4 the negative of -4?
Yes, sir.
But see, it still works. If you do that, it still cleans itself up, doesn't it? And the rest of it, you see, you get the same thing. This is complicated because I have this feeling that when you distributed the 4, the parentheses disappeared. Am I correct?
Mm-hmm.
They shouldn't have, because that negative was still out there. That negative was supposed to multiply not just to a 3 or to a 12, but to the entire parentheses. So when I present, I've been doing this for 100 years. At least I was doing this before the camera was invented. I have tried, well, I'm not always successful, to come up, the methods I usually show you are what I think are the ones that are easiest for the students, but that's not always the case. All right, let's try to throw some more of these up here. This is. I've been using this program for just about as long. Come here. Ooh, look at that one. We did that one right there. Look at that thing. All right. Now I should, once you get the idea, see if I'm going to use a phrase on you. You tell me if it makes sense. The problems I'm giving you are not harder.
but they are, I clicked the wrong thing. They're not harder, but they're more complicated. Does that make sense to you? That it's not harder, but more complicated. It's not, the steps aren't harder. They're just more. That's what I'm saying. So give this one a shot, see if you can simplify it. It's the same thing as the other ones. Simplify by combining the like terms. Same one with my mechanical pencil. They're nice to have. It's got most of its eraser, or some. You can have it, it's just lying there. We'll do it after everybody either shows me some indication that they've gotten or given up. I put the answer, anybody, did you guys get this? Yeah, I'm gonna do it anyways, but if you didn't, if you got stuck somewhere, let's see to find out where it was. When you approach the problem, what part of it did you try to do first? Which parentheses? All right, so you went and did those parentheses, okay. Now inside these, the parentheses, you couldn't really simplify anything. You know? All right, so leaving this here. You didn't do this part in here? This is what I would do first. Well, I would do this also at the same time, so I get 10W minus 15, end that block, or what do they call it, bracket. This minus is like a -1 going through. Are we okay there? That was just step one. Are we good? All right, what would come next? There's more than one thing you could do next, but what I would do is I would start working inside of these brackets and simplify it. So inside of the brackets, I can combine the 6 and the -15 and get -9 plus 10W. I'll pause there. Do you understand what I did? What's that? Yeah, the numbers are always like terms. Now inside of the brackets, I can't simplify anything anymore. So if I'm going to do any simplifying of the whole problem, I have to use the distributive property. So the negative is going to come through and change everything inside of those brackets to the opposite side. There's a minus in front of that bracket, isn't there?
Yeah.
That means change everything from negative to positive and vice versa. So you notice the -9 is now +9, and the 10W is now -10W. You can almost go straight across to finish this. 22 plus the 9 is 31. -10W and -7W is -17W. And then -16. And then all I have to do, what's 31 minus 16? 15. So you can choose to put the 15 in front or behind, it doesn't matter. 15 minus 17. All right, let's try another. So this is what I'm talking about. The individual steps are not difficult, but the whole thing, as it gets more complicated, you may lose track of where you're at. Let me grab another one out of here. And you can see the problems, they don't get any harder, they just become more hideous. Maybe they're not as hard as I thought. Okay, let's do this one. Probably coming along. Anybody else finished yet? Okay. I got 3x plus 19. Negative 3x. I got positive 3x. All right, let's take this. Oh, I guess we'll find out in a minute. 15 plus 4.
So this time it's a little more extended distributed. You got this 5 times each and everything inside of there. You got that, that, and that. So you got 20x squared plus 35x plus 15 minus 20x squared minus 32x plus 4. I'll pause there. You guys have that. But I happen to know I can't stand the 20x squareds. They just wipe each other out, don't they? They're gone. Now let's look at the x's. I've got positive 35 and I've got negative 32x. Combine them, what do you get? Positive 3x. 35 minus 32 is positive 3, isn't it? So that takes care of that one and that one. And then what's 15 plus 4? So 19. None of them are that bad. It's just, they could just be lengthier looking, that's all.
Should we try another one? Because we're gonna ratchet it up in a minute. This is not as hard as it gets. What could ratchet it up? Well, you can see right here. Do you see what's coming? What are those things? That's when it gets fun, right? It's not fun until there's fractions. Try not to grab any of the other problem. So these will definitely be more difficult because fractions are less than desirable for most students. Do you know what the number one trait of a successful math student is? Perseverance. You know that? I mean, the problem, either you're dead or the problem's dead by the time it's done. You know what I mean? But some students, especially, like in class like this, they see their fraction like, nope, I'm not going there. For the part that involves C, did you get 29C over 6? By silence, I'm guessing that's no. So let's take a look at how these multiply out. I'll give you another, there's more than enough to go around, so I'm not going to spoil the fun if I do any of this. You do this times this, what do you get for that part? Let's just do one part at a time. 2/3 times 6C.
4C.
So it's like 2/3. You might find it useful to put 6C over 1.
And then you can simply cancel, can't you, and simplify that.
I'm gonna do that in a minute. So this guy comes over here as well. By 2/3 times 7 over 1. I'm gonna move on to the second pieces. Here we get 5 over 12 times 2C over 1. Plus 5 over 12 is 5. It will be a 4C. It will be. Give it a minute though. I want to show you some steps. So why is it a 4C? Notice this. Doesn't 3 go into 6 twice? 2 times 2 is 4. There's your 4C. The next one, I can't do any kind of simplifying, so I can just multiply it across. -14 over 3. You okay with that? Similarly, I can't cancel anything in the next thing either. I can just multiply across. Well, no, I can do, except do you see any simplifying that can go on here? Any simplifying that can go on here? What can be simplified? We take this 2 out and make this into a 6, can't I? So we got 5C over 6. But I am stuck with this last piece. I can't simplify anything here. 25 over 12. So let's pause there. Did you guys get these numbers? See some tricks. Well, the next one will be something we're doing. Probably grab the odd version. What I would do next is I would probably move them close together to each other, just because it makes it easier for me. And I'm going to do one other thing too while I'm here. You can complain to me in a minute. I'll pause there and you can absorb what I did. Where did I get 24C over 6? And why would I take it and make it over 6 instead? I mean, this 5C over 6 came from over there. Where did that thing come from? 6. What is that thing? How did I get that? I find this interesting. Hey, it'll look directly there. You don't have to do the same thing. Why would I take that and do that to it?
Oh, that's right.
Why would I do that to it?
To add
Things, don't I?
same denominator.
I can't add one once doesn't have a denominator, one has a 6 in the denominator. I can't add those, can I? So I have to make them so that they're both over 6. Isn't 4 times 6 equal to 24? But multiply the denominator. Oh, it might help you, I guess, if you were to think of this as 4C over 1. Because if you got a bunch of fractions, you know you're going to have to combine them at some point. So all I did, instead of having a denominator of 1, I changed it to a denominator of 6, and then I moved some things around. Now, with that said, the other numbers that I have up there, this thing right here, how did I get to that? The 56 over 12, where did that come from? You can see the 25 over 12 is still there, it didn't have to be changed. But that, 56 over 12, why is it there?
If you have to multiply the 3.4.
That's right. So if you look at the numbers I have a fraction and a fraction. The only way to add up fractions up is with the same denominator. One has a 12 and one has a 3. They both need to be over 12. Do you agree with that? So if I change this to 12, what is 3 times 4? What is 14 times 4? Now I'm ready to combine everything because they all have denominators for combine. Tell me what the C part of it's gonna be.
No.
That's right. 29C/6. And then what about the number portion? What do I got for that? -31 over obviously you need to do another one. I can tell them by the 5 of them through that so well now. All right, so let's pop over here. Make another similar one, see what we can do. 92, well, your last shot here, your last shot. 92 looks fairly similar. The odd ones I generally don't do in class because the odd ones have the answers right underneath of the problem. Do you guys see that? So I figure I don't want to take those away from your practice. All right, when you get it correct, you can be done for the day. I just did the first step. I'm looking at the time, and I may not have as much time as I think, but that's my very first step. Does it match your first step? But all we gotta do is make sure, and I did a teeny bit of simplifying while I was there. I still think it's a good idea to take your numbers and put them together, put your like terms together. So I'm gonna put my y's up front. I'll shove the numbers to the back. Outlaws there. Once again, what is the property they use to move stuff around? Move everything all over the place. Now, notice the parts that involve the y's. Did you notice they already have the correct denominators? I can just put them together. When I put those two things together, what do you get for the y part?
But how did you get 9 over 5y?
9 over 5y. I did two steps at once. I multiplied it through, and I noticed that this is 18y over 10.
Oh, so you broke it down. You said,
I said, well, yes, I did it in one step. That's right. That was an 18y over 10. That's exactly what that was. So I was kind of simplifying as I went along. And then I went, you know what, I'll tell you what I'm going to do. I think it's probably a good idea if I show that stuff, but I can do it. I'll put it in this spot, and then maybe it will be seen. So that was negative 18y over 10. So then maybe you can see that it turned into that. Then I put the numbers together. Now, but let's take care of the y's first. When I combine those y's, you should see there the negative 9 and the negative 8. What's negative 9 plus negative 8? Think about this. Suppose you're standing on top of negative 9 on the number line. If I have negative 8, go that direction or that direction? If you add negative to a number, do you go to the left or to the right? Is 1 over there? You're negative 9, 1 is nowhere over there, is it? So you got to go to the left. So what's 9 plus 8? So that's actually negative 17y over 5. Now, to do this other part, I'm going to have a common denominator of what? No, you can't go lower. 15's not going to work with 10, is it? 30. 30 will work with all of them. So that's going to be 14 over 30 minus 27 over 30 plus 36 over 30. Chances are your calculator will actually do this for you. Did you know that? And it will combine them too and simplify them all in one shot. But I did all over 30. What do you end up with if you do this? Just go with me as I go. What's 14 minus 27? Negative 13. Negative 13 plus 36. 23. So I didn't do anything to the fraction on that last step. I still have negative 17y over 5. But then I have plus 23 over 30. How far? I'll leave that up. Are there any questions about it? I will go ahead. So I can't put that in class for today. Did you have a question?
yeah, because I was gonna say, I noticed I messed up when I was going down, because when I was looking at it, and so when I was looking at the board, looking at it, writing it out, put in the negative 2 over 5 and took 4 over y. did that, I did that, five,
Right.
the 8y over five, the negative 8y over five, and then when I had my, because I didn't simplify it, so I had kept 18, I had kept 18y over 10.
Maybe that's 16y over 10.
The,
At some point, you're gonna have to combine them.
right, because yeah, that's my problem when I noticed, because once when I combine those two with the 8y over 5 and the 18. Yeah, the 8y over 5, the negative 8y over 5 and my negative 18y over 10, when I combine them, I end up except not paying attention to the 18 over 10, dropping it. I put them together. I put them together like doing, starting making the denominator the same. So that's changed mine completely. Got mine completely wrong because I ended with yeah. When I was, yeah, I ended with 2y over 10 and turned into 1y over 5.
Okay, yes, 2y over 10 is 1y over 5, that's true. How did you get 1y over 5?
So once again, like when I had the second one, when I distribute the negative two over 5 into the 4y.
You get negative 8y over 5.
Yeah, 8y over 5, and then because when I was looking at it, I'm like, I have this 18y over 10, and I have this negative, and then I have this 8y over 5, and that I made it 10. I ended up making it 16 over 10. I turned that to 16 over 10, and I subtracted the two together.
That's okay, 16. So when that's 16 over 10,
That's 16 over 10, so that means
9 over 5,
16
negative
over 10
17.
minus 18.
That's 34.
Oh, see, that's where I went wrong, because I wasn't paying attention to my negative positive. So yeah, I went down. I actually went down instead of I went up instead of going down.
Okay.
All right, so